Okay, today we're going to be working on 6.3. We just finished 6.2 in the previous video from before spring break. So this is our section for Monday, April 6th, 6.3. So we're on page 10 of our note packet. So what we're going to learn in this section, this is a super fun section, is how to simplify radicals. So the multiplication, let's see if I can talk. The multiplication property says that if we have two radicals that have the same index, we're allowed to write them under a single index. So as an example here, these both have an index of 2. Therefore, we're allowed to write them under a single index and do whatever operations there, 5 times 75. Then I get square root of 225, which is just 15. 15 times 15 is 225. But I can also go the other way. This is a double. You can go from 2 to a single, or you can go from a single to 2. So let's say I'm stuck on this problem in Math 150 and they don't let me use a calculator. And I don't know what the square root of 144 is. Well, I can break it down. So 4 goes into it because 4 goes into 44, and it goes in 36 times. And then I can say the square root of 4 is 2. The square root of 36 is 6. 2 times 6 is 12. That means 12 times 12 is 144. So you can go from two separate radicals to a big one and then simplify, or you can go from a big radical to two separate radicals and simplify each one of those separate radicals and multiply the answers. So, how do we know when a radical is simplified? So there's 3 things we have to look for. So a radical is simplified if the radicand has no power higher than the index. So this would not be simplified because the power of the radicand is higher than the power of the index. So let's write not simplified. So that's what that first rule is saying. And this is what we're going to learn how to do in this section, how to simplify ones like this. In a couple sections we're going to learn how to deal with these two, but not in this one. Another thing that means your radical is not simplified is when your radicand has a fraction. So this would be another example of not simplified because I have a fraction as my radicand, or what's under the radical. And last, another example of what's not simplified is having a radical in the denominator of a fraction. I'm never allowed to leave an answer with a radical in the denominator. So like I said, in a couple days, we'll work on these. This is in the division section. Today we're going to work on how do I simplify that. So this example is a good one to look at. So do you all agree that x to the 8th is x times 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 x? 8 x's, right? Well, think back to the very first section of this chapter. Remember how we learned that x to the 5th root is just x? We learned to do 5 divided by 5 and get 1. So what we're looking for is groups of 5, because every group of 5, because the index is 5, every group of 5 will come out as a single because of this. So we learned that when you have an index in this number, you take this number divided by the index. 5 divided by 5 is 1. So anytime you have 5 x's under the radical and the index is 5, it comes out as a single x, and then these 3 x's will stay under. So that comes out as a single x, and then we have the 5th root with 3 more x's underneath. And again, the reason why is because 5 x's come out as a single x. I like to think of this as jail. In order to get out of jail, you have to have 5 of something. Well, here's 5 x's, and you come out as a single. But if you don't have 5, then you have to stay under. And here we just have 3. That's not enough to get out of jail, so that stays under the radical. So let me show you one. Maybe it'll make more sense as we go through. So this one, the index is 3. So I'm looking for triples of things. So the index tells us how many we're looking for. Circle 5 and they come out as 1. This is going to say circle 3, they come out as 1. One of the numbers I told you to memorize was 32. Some of you may remember it's 2 to the 5th. Some of you may not. So you can do a tree at any time if you forget. So 32 is 2 times 16 or 4 times 8. Doesn't matter where you start. Every time you get a prime, though, do circle it. And then this is 2 times 8. And then 8 is 2 times 4. And 2 is prime, so I keep circling it. And then we got 2 times 2. So remember how I said memorize that 32 is 2 to the 5th? There you go. There's the 5 2s. That's where it came from. So watch this. So 2 times 2 times 2 times 2 times 2. So there's my 5 2s. And then you should recognize that there's 4 x's. So again, like I said earlier, you look at the index and that tells you how many to circle. So every 3 will come out as a single. Nope, not 3 there. Every 3 will come out as a single. And when they come out, it is multiplication, just like it is underneath. So I can see my answer is going to be 2x. And then there's not enough 2's here to get out of jail, not enough x's there, so those have to stay under. So I do 2 times 2, 4, and bring down that x. So anything that's not circled stays under. Anything that's circled come out as a single. So the cube root of 2 cubed is 2. The cube root of x cubed is x. So 3 of anything comes out as a single. 3 of anything comes out as a single. So 2 times x is outside. And then cube root, what's left? 4x. So, isn't that fun? I think it's like big fun. So what I would do is I would turn off the video now and see if you can do the same thing with letter B. Okay, so letter B, I know 32 times 2 is 64. Everybody agree? 32 times 2 is 64, so wouldn't I just add another 2? So instead of 5 2's, it's going to be 6 2's. And if you didn't figure that out, you could do a table for it. So the minute I see 64, I'm going to put 6 2's. Oh, gee, wow, wow. How about 6 2's? 1 2 3 4 5 6, 2 x's, and a y. So how many pairs did you circle when you tried this one on your own? Does everybody agree I'm circling groups of 2? Because this is an index of 2 whenever there's no number there. So that one's going to come out as a 2. This one's going to come out as a 2. And this one's going to come out as a 2. And this one will come out as 2 x's, come out as an x. And I keep putting my multiplication up there just to remind students that it's multiplication. So 2 2's come out as a single, because this is square root. 2 2's come out as a single. And ask yourself, is the square root of 4 2? Yes. Is the square root of 4 2? Square root of 4 2. Square root of x squared x. So it all makes sense. So on the outside of the radical, we have 2 times 2 is 4 times 2 is 8. And we have an x. Underneath the radical, all we have left is y. I believe it's 3 problems like this on the test. 1, 2, 3. Yep, so 3 simplified problems like this on the test where you can just circle the groups. Always look at the index. That tells you how many to circle, and each group will come out as a single, and then you just multiply those all together. 2 times 2 is 4, times 2 is 8, and x is outside, and the only thing left under that doesn't have enough to get out of jail is the y. Okay, let's go ahead and look at page 11. So we'll do these top 4, and then we'll take a little break. So 108. That's going to be kind of a big number to make a tree for, but no problem. So my recommendation when you see this, does everybody realize that means the answer is going to be negative? So I would put a negative right there, and then you don't have to worry about it. It's already in your answer space looking ready for you. So I need to make a tree for 108. I need to make a tree for 125, and then I have 6 x's. And I'm going to make some of these exponents a little smaller, so don't work ahead yet. I want to make these smaller just so we don't have so much writing to do. Okay, so let's go ahead and make a tree for 108 and see what that looks like. So do you remember from the other page, whenever there's nothing common, you can split it into 2. This was called the quotient property that we went over earlier. So this is really cube root of 108 x to the 6th with a negative over cube root 125. So that was the quotient rule that said you can write it as 1, or you can split it up into 2 separate. And in this case, if there isn't anything common to simplify, it's much easier, and just do it as 2 separate problems. Do it like that's a problem, and then do it like that's a problem. So we need to make a tree for 108. So let's go ahead and do that. So 108. So that is, let's see, it's even. So let's start with 2. Half of 10 is 5. Half of 8 is 4. 2's prime, so circle, because some of these are going to be so long, it'll be easy to lose your prime. So you probably want to make sure you circle it the minute you see a prime. 54 still even. So I'm going to divide it by 2, and it goes in 27 times. 2's prime, so I'm going to circle it. And then we have 29, which is 3 times 9. 9 times 3 is 27. 3's prime, so I'm going to circle it. No, I'm almost done. Yay! So there we go. It's looking like 2 2's and 3 3's. So this is going to turn into, oh, I hope I have room there, 2 2's, 3 3's, and I had someone ask me, because the 121 classes have already learned this, and they're like, what if we're not very good at the tree? How can we check this? Just type those numbers in your calculator, and you should get that back. 2 times 2 is 4, times 3 is 12, times 3 is 36, times 3 is 108. So it should always give you back to your original number. And then we have 6 x's. I'm going to have to write small here. 3, 4, 5, 6 x's. So there's my new numerator. 125, if we did a tree for that, so let's do 125 over here. It's going to be 3 5's, because 5 goes into it 25 times. 5 is prime, so you can see 125 is 3 5's. So 5 times 5 times 5. So I haven't done anything tricky yet. All I did was factor everything under the radical, because now I'm looking for triples. So circle all your triples. So there's not enough 2's to get out, but look at this. There are 3 3's. There are 3 x's. and there are 3 more x's. So this is going to come out as 3 times x times x. So the numerator is going to be negative 3x squared. And then what's left under the radical? So let's see what didn't get circled. 2 times 2, 4. So that's my new numerator. 3 came out, an x came out, another x came out. I have the negative there, plus I already have it there. And then the denominator, what's the denominator going to be? Whoops. 3 5s come out as a single 5, so there's no radical left. There's a triple, it comes out as a single 5 and nothing's left under the radical, so there's my answer. So it looked really, really complicated, not bad at all. So now we can go up to the answer blank and fill in our answer. If you want to keep the negative in the middle like they have it, 3x squared cube root 4, and don't lose your index on that. And the denominator is just 5. And a lot of students are confused, like, where did the radical go? Well, if all 3 of those 5 came out as a single 5, there's nothing left under the radical. It's empty, so that's why we took it off. So 3 came out of jail as a single. Nothing was left under the radical, so there's no radical in the denominator. So that is your answer. So let's make these numbers a little bit smaller on this so we're not writing off the page. Let's make this 6. And let's make this 4. So let's say 4 times 4th root of 64. So this is our new problem. Let's just make it a little bit easier. We'll keep the x to the 7th. We change the y to the 6th. And we change the z to the 4th. So I'm just making the numbers smaller just so these problems don't take forever. I made it come out the same kind of answer, but I just wanted to make the numbers a little bit smaller. So you may be wondering what's going to happen with that 5 out in front. Well, anytime there's a number besides something with no symbol, that means times. So you should keep that time sign out there and remind yourself, oh yeah, times whatever comes out is going to get multiplied by 5. Well, if you look on the last page, 64 was 2, 4, 6 2's. So we already have that simplified from the other page. Oh, I hope we can fit this all on. We'll see. So 5 times 4th root. Let's make a big long one. So it's going to be 6 2's. And if you didn't remember that, or you would just do a tree just like we did here, but we had done it earlier. 7 x's. 6 y's. Running out of room there, aren't we? And 4 z's. I'll put those up here. And this is 4th root. So we're going to go down the list and we're going to circle groups of what? 4, right? So the index is 4. That tells me to circle groups of 4. 1, 2, 3, 4. 2 2's left over. 1, 2, 3, 4. 1, 2, 3 x's left over. 1, 2, 3, 4. 2 y's left over. 1, 2, 3, 4. No z's left over. So from that, you should be able to say this is going to be 5 times 2 times x times y times z. Because remember, anything, 4 of anything comes out as a single. So 5 was already there. These come out as a 2. These come out as an x. These come out as a y. These come out as a z. So 5 times 2 times x times y times z. And then we have 4th root, and let's see what's going to stay underneath. So 2 2's, 2 times 2 is 4. There's not enough of those to get out of jail. There's only 2 of them. And there's 1, 2, 3 x's, so that would be x cubed. There's 2 y's, so that would be y squared. No z's left, because 4 z's came out as a single z. So now I can see my final answer is 10x, y, z, 4th root, 4x cubed, y squared. So let's go ahead and put that up in our answer blank. So 10 x, y, z, 4th root, 4, 3 x's were left underneath, and 2 y's. So 4x cubed, y squared. And that would be your answer. Like I said, I put 3 of those on your test, so practice on Alex. Everybody thinks they're really fun by the time we take the test, and they are really fun. They're easy. You just kind of have to get the hang of it. Okay, let's do one more of these. Well, actually, neither one of these are too hard. We can do both of these. So we'll do these 2, and then we'll stop and take a break. So this 4, because it's a fraction, you might want to write it like this. Because 4 is really 4 over 1. So I would write it as 4 over 1. And then there's nothing common here, so let's split this up. So I'm going to show you a trick on these that works really nice. So you don't have to write 16 x's and 9 y's. So watch this little thing, because this is what you'll use in real life anyway by the time you get to the test. So there's the numerator, and then the denominator is its own radical, right? So my goal, rather than write 16 x's, that's going to take forever, right? My goal is to make sure all of these are divisible by 4. Is 16 divisible by 4? Yeah, so leave it alone. Is 9 divisible by 4? No. So what's the largest number less than 9 that is divisible by 4? Well, 4 times 2 is 8. So I can divide y to the 9th up into y to the 8th and y to the 1st. Isn't that still y to the 9th? Because we learned that multiplication means add the exponents. And then we have az cubed. And the reason I left it cubed is because 3's not divisible by 4, 2's not, 1's not, so z cubed is going to have to stay in jail. So any exponent that is divisible by 4 can come out, because remember how we learned on the first day, you do 16 divided by 4. 8 divided by 4. And so we can write what this is going to be. 16 divided by 4 is x to the 4th. 8 divided by 4 is y to the 2nd. So that's what's coming out, and the things not circled don't have enough to get out of jail, so they're going to stay under. If we do a quick little tree for 16, you'll see that it's 4 2's, 4 and 4, 2, 2, 2, 2. So 16 is 4 2's when we go to write it as a radical. So we'd write it as 2 times 2 times 2 times 2, or we could write it as 2 to the 4th. And remember how 4 of anything comes out? So can you see that there's not going to be a radical on the final answer? Because those 4 2's are going to come out front as a single 2, and there's not going to be anything left. Because 4 of anything comes out as a single. So now let's look at this mess and see what we have. So there's the 4 from up front. 16 divided by 4 we said was x to the 4th outside the radical. Once you do that division, they're outside. 8 divided by 4, y to the 2nd. And then we're going to have the 4th root of yz cubed. Almost done. And 4 2's come out as a single 2, and that's all there is. There's absolutely nothing else left in the denominator because those 4 came out and nothing's left. Then we have one final thing we can do. This is actually from chapter 5 that you just took your test on, that you never got back. I still have them in my bag. So remember how we learned we can cancel on the diagonals? 2 goes into 2 once, 2 goes into 4 twice. So now I can write my answer as a single. Do you see now it's not a fraction? See how the denominator is 1? So my final answer is just going to be 2x 4 y 2 times the 4th root of yz cubed. Because now the denominators are both 1, because 2 goes into 2 once, 2 goes into 4 twice. Denominators are both 1, so you can leave 1 off. 1 times 1 is 1, so we just multiply the numerators. 2 times x to the 4th y squared is 2x4y squared. 4th root yz cubed, and that would be my answer. Busy, 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 busy problem. So let's bring f down here, since we kind of jacked its room, didn't we? So f is 4th root of y cubed over 81. And this is just a one-step problem. That's why I moved it down here. So nothing common between these two. So our quotient rule tells us to break it up into 2 separate fractions. So it's going to be the 4th root of y cubed over the 4th root of 81. So anytime there's nothing common, no canceling, we split it into 2 and do it like 2 separate problems. So we do this first. Are there enough to get out of jail? Nope. So that's going to stay 4th root of y cubed because there's not enough to get out. But 81 is 9 and 9. 9 times 9. So that's 4 3's. 4 3's will come out as what? 1, 2, 3, 4. Does everybody agree 4 3's are going to come out as a single 3? Because we need 4 for it to come out. And do you see how nothing's going to be left under the radical? So it'll just be a 3 out in front, nothing in the radical, because 4 of anything comes out as a single outside. So my final answer is just going to be 4th root y cubed over 3. And we are done. Yeah, those are pretty heavy duty, some of those, huh? Okay, let's take a break and we'll come back and finish 6.3 in our next video.